Okay, so today we're going to go through a few statistics problems. Okay, in the first one, we're given the house prices in US dollars in a small town. So the first question asks us to find the mean and the median. So we'll start with the mean. The mean is simply the average of the set of data. So we're in both mean and median, we're trying to find the center of a set of data. It's just two different ways to do it. So for the mean, you're going to take all of these values, add them together, and then divide by 8. You divide by 8 because there are 8 separate data points. So you get the sum and then divide by how many data points there are. So once we do that and we get the sum of that and we divide it by 8, we should get a mean of 224,500. So it's the mean. All right, so moving on, we know the mean is 224,500. So now we got to find the median. So for the median, we're going to do something slightly different. So to find the median, you're just going to cross off until you're left with either one or two different data points. In an odd set, you'll get just one, and in an even set, you will get two values. You average them together, and that's your median. So we'll start cross off, cross off, cross off, cross off, until we're left with these two values. So now we're going to get the average of these two. So we'll add these two together and divide by 2. And whenever you do that, you should get 147,500 as the median. So there's the median. So the second question I state which measure best represents the typical house price here and explain why. So the best measure would be the median. It's the median because the median is less resistant to outliers. If we look at this set of data, we have most of our data is concentrated between 120,000 and 154,000. However, there's an outlier of 800,000, and that outlier makes the mean go up. So the median would be better because it's more in the center of this set of data than the mean is. 224,000 is somewhere in here, but that's not where most of our data is. Most of our data is somewhere right in here. Okay. And explain how an outlier affects your answer. So the outlier mainly affects the mean because it made our mean pretty drastically bigger than our median. Okay, then problem 2, 5 number summary box plots and outliers. So we're given a set of exam scores. And we're asked to find the 5 number summary. The 5 number summary is made up of the minimum value, Q1 value, median, Q3, and maximum value. So now we need to identify all these. So we can start with our minimum. Uh, well, our minimum, or the smallest number, is 55. So 55 is equal to our minimum. Okay. And so then we're asked to find, so next we can move to the max. The max is, we'll identify the minimum and maximum first. And the max value is 95. So 95 is equal to the max value. 95. And then from there we can find the median. So we'll do the same steps that we did as the first problem. So cross out, cross out, cross out, cross out, cross out, cross out. And we're left with a median of 70. Then we got to find Q1. So to find Q1, we're simply going to take the median of this set of data. So from the minimum value all the way up to the median. So we'll do the same thing. We'll cross off, cross off, cross off, cross off, and we get a Q1 value of 62. and we got to find Q3. So Q3 do the same steps as Q1. We're going to find the median from here to here. So solve, 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 solve. We're left with a Q3 value of 80. So that is the 5-number summary. All right. And then we need to find the interquartile range. The interquartile range, I Q R is equal to Q3 minus Q1. So Q3 is equal to 80 and Q3 is equal to 62. And if you subtract those two, you should get an interquartile range of 18. So that is equal to our interquartile range. Then identify any suspected outliers using the 1.5 time IQR. So what we're going to do for this is we're going to take the IQR and we're going to multiply it by 1.5. So 1.5 times 18. And then to find if there's any suspected outliers, when you multiply those two together, you should get 27. Double check. 1.5 to 8 is 27. So what we're going to do once we have that number, we have 27. To find if there's any suspected outliers, we would add 27 to our Q3 value and we would subtract it from our Q1 value. So if you take 62 minus 27, you get 35. However, when we look at the set of data, there's no values that are less than 35. So there's no suspected outliers on the left side of the graph. And then we take the 27, add it to 80, 27, add it to 80, and we get 107. And there's no value that is exceeding 107. So there's no suspected outliers. So none. And then draw a box plot based on the results. So the box plot is made up of the 5-number summary, which we have over here. So for that, we'll use this line, or no, actually maybe we won't. Okay, so we'll have 55. Then we'll have our Q1 value, which is 62. And we'll have our median value, which is 70. Q3 value, which is 80. And then our maximum, which is 95. Yes, 95. So from there, we take a line and we draw it to the Q1 value, put a little into it there. So from 55 to 62, it's just a line. Now from Q3 to median, we draw a box. And so the box starts at Q1 and ends at the median. And then we'll draw another box from the median to Q3. And then for the final step of our graph, we'll do the same thing as we did from the minimum to Q1. So from Q3 to the max, we would draw a line. So that's the box plot for number 3. And based on your results, describe the shape slash skew or the symmetry of it. So from this, we see that our outlier is to the right and most of our data points are to the left. So whenever we see that, we know that the data is skewed to the right because the outlier is to the right. So wherever the biggest outlier is, that's which way the graph is skewed. So for this one, it'll be, and it's slightly, it's not a huge symmetry difference, but it is slightly skewed to the right. Okay, so skew to the right. So that should answer all the problems from that. So I'll erase all this, get rid of it. So for problem three, it says the package weights shipped by a company are approximately normal with a mean of 12 and a standard deviation of 2. So number one asks us what proportion of packages weigh between 10 and 14 pounds. So to answer this question, we need to know the 68, 95, 97 rule. So we're going to draw standard normal distribution. And so in standard normal distribution, the mean is always 0 and the standard deviation is always 1. Give me a second to draw this. Okay, so the 68, 95, 99.7 rule states that from one standard distribution below the mean and one standard deviation above the mean lies 68% of the data points. So 68. And then from two standard deviations below the mean, two standard deviations above the mean lies 95% of our data. And then from three standard deviations below the mean, three standard deviations above is 99.7% of our data in standard normal distribution. Okay, so it's asking us what is the proportion of packages that weigh between 10 and 14 pounds. So we see that the mean is 12. So the mean is 12, and the standard deviation is 2. So 12 plus 2 is 14. 12 minus 2 is 10. So we know that these two are both one standard deviation from the mean. And if we revert back to our rule, we see that from one standard deviation below the mean to one standard deviation above the mean lies 68% of our data points. So what proportion of packages weigh between 10 and 14? It would be 68%. Okay, and then what proportion weighs more than 16 pounds? So 16 is two standard deviations above the mean. And we know that from two standard deviations above the mean and two standard deviations below the mean, 95% of our data lies in between those 2 points. And so if we know that, then we know that there's 5% here, or there's 5% between these 2 points. So to find what proportions weight just in this area, we have to take that 5% left over and divide it by 2, and then we get 2.5%. And then we use this rule, right? Justify it. We did that as we did the problems. All right, and then problem four, finding a value given a proportion. So it says, assume SAT math scores are normal with a mean of 500 and a standard deviation of 100. So we're trying to find the score that marks the top 10% of students. So there's a very crucial formula we have to know. We have to know that the z-score is equal to x value minus the mean. Mean is x bar. It's another way to represent it, all over the standard deviation. So we're trying to find the top 10% of students. And so to find the top 10%, we need to find a z-score that we can plug in. We know the mean. No, the mean of this data is 500, so we can plug in 500 here. We know standard deviation is 100. Standard deviation is 100. And we're trying to find this value. So now we have to go to our z-score chart. Let's see our z-score chart, and we're looking for one of these proportions that is about 90% of our data. So when we look, we say that 0.28, so this number right here is closest to 90%. So we're going to use 1.28 in the formula. See if I can get back. All right, so we know that 1.28 would be our z-score. So if we rewrite that, it's 1.28 is equal to x minus 500 over 100. And with simple algebra from there, so multiply 1.28 times 100 and then add 500, we get the score that marks the top 10%, which is 628. All right, then we need to find a score that marks the bottom 25%. So we're going to take the same step that we did right here, the same formula. We're going to try and find a z-score that's close to 0.25. So we're going to go back to our z-score chart, and right there, the one that is highlighted is closest to 0.25, and that is negative 0.67. Negative 0.67. So negative 0.67 is equal to x minus 500 all over 100. And same simple algebra, 100 times negative 0.67 plus 500 gives us a score of 433 that marks the bottom 25%. Okay, so that is how you solve these four problems.